Right now, somewhere in a natural history museum, there's a reconstructed mammoth skeleton standing behind a rope barrier. You can walk right up to it. You can look at the tusks, which are about as long as a pickup truck, and think about the fact that some human being with nothing but a sharpened stick and a group of friends decided to kill one of those things. And not just once, regularly. As a food strategy, when you actually sit with that, it stops making sense. These weren't small animals. They weren't slow, and the people hunting them didn't have anything close to what we'd call an advantage. So how did they actually do it? Let's start with what ancient hunters were actually up against. Woolly mammoths weighed somewhere around 13,000 pounds and stood between 10 and 12 feet tall. Saber-Toothed cats, the ones sharing territory with early humans around 300,000 years ago, weighed up to 750 pounds and had canine teeth long enough to stab through your torso. Giant prehistoric catfish, hunted in Central Africa over 70,000 years ago, weighed as much as 150 pounds each. These weren't edge cases. This was the menu, and early humans were going after all of it, which means they had to be extraordinarily clever about the approach. The first thing you have to understand is that ancient humans weren't fast. Not compared to what they were hunting. A charging animal outpaces a human sprinter without much effort. But here's the thing. You don't have to be faster if you can outlast something. Researchers Daniel Lieberman of Harvard and Dennis Bramble at the University of Utah have spent years arguing that persistence hunting was one of the earliest strategies humans used. The idea is straightforward. You find an animal, you chase it, not at full speed but steadily. You keep going and you don't stop. Quadrupeds cool down by panting, but they can't pant effectively while running at the same time. Humans sweat. That difference is enormous over long distances in hot environments. Eventually the animal slows. It collapses from heat exhaustion, and then you close the gap. This strategy sounds almost too simple, but it required something more sophisticated than raw endurance. It required knowledge. A persistence hunter needs to track an animal across terrain, read its behavior, anticipate where it's heading, and coordinate with other hunters across distances. You can't just run after something and hope for the best. You have to understand the animal well enough to predict it. That's a level of cognitive work that most other predators simply don't do. No lion is running a strategic intercept. No wolf is reading the terrain 3 miles ahead. But humans were doing exactly that. Then there are the weapons, and this is where things get genuinely impressive. The earliest projectile points we know of show up around 279,000 years ago in Ethiopia's Rift Valley. Hunters there were shaping volcanic glass into sharp points and attaching them to wooden shafts. What they built was essentially a javelin, and the key word there is distance. A wooden spear you can thrust at close range is one thing. A hafted projectile you can throw from 20 feet away is something else entirely. It puts space between the hunter and the animal. That space could mean the difference between walking home and not. Much later, around 10,000 years ago, humans developed the atlatl, a spear thrower that used leverage to fling a dart or spear at much higher velocity than an arm alone could manage. The physics work in your favor. You're essentially extending the length of your arm, which increases the force and the range. Someone with an atlatl can launch a projectile with enough speed and accuracy to bring down large game from a distance where the animal barely registers the threat. It also matters that there's evidence of this in cave art. A 12,000-year-old cave painting from Altamira in Spain shows hunters using exactly these kinds of outflanking movements, coordinating around prey in ways that look surprisingly tactical. And then there's a technique that most people have never heard of, which is called pike hunting. Researchers studying the Clovis people of North America, who lived about 13,000 years ago, found evidence suggesting that hunters would sometimes plant their spears in the ground with the points facing upward. Then they'd drive the animal toward the spear. The animal's own weight and momentum did the rest. Experimental tests with replica Clovis points showed that a thrown or hand-thrust spear often didn't generate enough force to penetrate the thick hide of a mammoth or mastodon, but a braced spear using the animal's own charge generated force that stone tips alone couldn't replicate otherwise. This wasn't a crude solution, it was an engineering insight. You're turning the animal's strength against itself. The trap pits found in Mexico tell a similar story. Archaeologists found mammoth bones distributed across 2 large excavated pits, and the arrangement is hard to explain any other way. Hunters dug these things deliberately. That means planning, labor across multiple people, and a coordinated effort to drive animals toward a specific location. You have to know the terrain. You have to know the animal's movement patterns. You have to build something that doesn't exist yet, and trust that it will work when the moment comes. That's not instinct. That's strategy. Poison adds another layer to all of this. Some of the earliest chemical evidence of poison use dates to about 24,000 years ago, found at Border Cave in South Africa. Researchers identified traces of ricin, a highly toxic compound derived from castor beans, on notched wooden applicators. These were likely used to coat arrowheads or spear tips. The San people of southern Africa still use a similar technique today, and the reason is practical. Bone-tipped arrows often don't cause enough immediate damage to kill large prey, but a poison tip that delivers a toxin into the bloodstream changes the outcome entirely. You hit the animal once, then you follow it, and you wait. This is persistence hunting taken one step further, the toxin doing the long-distance work while the hunter tracks from behind. What made all of this possible was cooperation. Large animal hunting almost never worked alone. Chizim Cave in Israel has produced faunal assemblages from between 400,000 and 200,000 years ago, showing that hunters were targeting prime-age deer, processing the meat carefully, and bringing it back to a central location. The highest quality cuts were delayed for consumption until the group could share them together. That's not individual behavior. That's a social system built around a hunt. The coordination required to pull off something like that, moving animals, dividing roles, sharing the result, contributed directly to the development of more complex social structures. Here's something that changes the picture even further. For a long time, the assumption was that big game hunting was almost entirely a male activity. Then archaeologists found a 9,000-year-old burial in the Andean highlands, a young woman interred with a full kit of hunting tools, including projectile points designed for use with an atlatl. Researchers went back through 27 other skeletons from the same era and region that were buried with similar hunting implements. About 41% of them were likely female. That's not a statistical anomaly. That suggests that both men and women were actively participating in large-game hunting in early American hunter-gatherer societies, which means the entire cooperative hunting system was more inclusive than anyone had assumed. The saber-toothed cat presents a specific problem worth thinking about. A mammoth, for all its size, was a herbivore. It wasn't hunting you. A saber-toothed cat was a different story entirely. These animals were apex predators sharing landscapes with early humans, and they were built for killing. Massive shoulder muscles, powerful forelimbs, and those teeth, which scientists now think were actually somewhat brittle and needed to be used with precision rather than brute force. The cat would pin prey down first, then deliver a calculated strike to the throat or abdomen. Hunting something like that required understanding how it attacked and staying outside that attack pattern. Projectile weapons and group coordination weren't just useful here. They were likely the only reason the hunt was survivable at all. What's striking about all of this is how much of the success came from information rather than physical capability. Knowing where animals migrated seasonally, knowing which terrain features could serve as natural traps, knowing which plants were toxic and how to apply that toxin, understanding the physiology of a predator well enough to exploit its weak points. This is knowledge being transmitted across generations. Someone learned that the saber-tooth's teeth could snap on bone. Someone taught that to the next person, and that chain of shared information stored not in any object but in human memory and social connection was the actual weapon. Everything else was just the delivery mechanism. By around 13,000 years ago, humans in what is now Mexico were digging organized trap pits large enough to immobilize mammoths. People in South Africa were applying chemistry they couldn't name to weapons they'd spent hours crafting. Hunters on multiple continents had developed throwing technology precise enough to take down fast-moving prey at distances that kept them safe from retaliation. None of this happened by accident. It accumulated, slowly, over hundreds of thousands of years of trial and refinement, passed between people who needed it to survive. The animals were bigger and faster and stronger, but they were working alone.